I'm Anil Kumar. Welcome to my series on vectors. We'll discuss unit vectors in this particular video. Now, what is a unit vector and how do we work with it? To understand this, I've taken up few questions. We'll answer these questions and understand the concept. The very first question here is, find a unit vector in the given direction. A, 3 minus 4, B, 1, 2, 3. So we have taken a case which is 2D and we have taken a case which is in R3, 3D. Question number 2 is, write velocity vector for a car traveling southeast with speed of 60 miles per hour. In this case also, we'll first find a unit vector in the given direction and then multiply it by 60 to get the velocity vector in that direction of magnitude 60 miles per hour. Question number 3 is very interesting. Can the sum of two unit vectors be a unit vector? You can see this question many times in test papers. Related with this, we have another question. If sum of two unit vectors is a unit vector, find the magnitude of their difference. Now you must have seen the third question many times in the test paper. Now I think it's a turn for question number 4 to come in test papers. So if the sum of two unit vectors is a unit vector, find the magnitude of their difference. We'll look into these questions one by one and I hope it is going to help many students. So let's begin with the very first one. How to find a unit vector in a given direction. Now here is the question. Find a unit vector in the given direction. So let's begin with 2D case where we are given a vector 3, 4. Now when I say vector 3 minus 4, it really means what? It means that on Cartesian plane, we can actually sketch a position vector. So 1, 2, 3 and 1, 2, 3 and minus 4. So that is the vector we are talking about. So this vector is 3 minus 4. Now when we say unit vector, what should we do? We should first find magnitude of this vector. Right? So let's call this vector as A. Right? So let's say vector A is given to us as 3, 4, then magnitude of A, let me write like this, will be equal to square root of 3 square plus 4 square. So I've taken very easy numbers to work with. 3 square plus 4 square square root is 25 square, which is 5. So this length, which gives you the length of A, is 5 units long. If I am saying a unit vector, that means 1/5 of it, correct? So that becomes 1/5 of it. That is what we are looking for. So therefore, the unit vector of A, which we normally write like this, so that is a representation for unit vector, could be written as the vector A divided by its magnitude, which we just found. Now that means 1/5 of this, right? That means 1/5 of the vector 3 minus 4. You get the concept, correct? And therefore the solution for us will be 3 over 5 and minus 4 over 5. So that is how we get the unit vector for any given vector. Let's say this is O, this is point A, In that case, as you saw, the unit vector OA will be represented as 3 over 5 comma minus 4 over 5. Perfect. So I hope with this sketch it is absolutely clear how do we find a unit vector. Now in R3 also it is same scenario. So what we'll say is, let's say this is our vector B, right? In that case, let's find the magnitude of B. Magnitude of B will be 1 square plus 2 square plus 3 square. And that gives you 1 plus 4 plus 9 or square root of 14. And therefore, the unit vector of B is going to be, now square root of 14 we will divide all this with, right? So it could be written as 1 over square root of 14 times 1, 2, 3. Correct? Now it's a normal nomenclature that we don't divide by a square root, we rationalize it. So you could also see this answer written as square root of 14 over 14, correct? Times 1, 2, 3. Perfect. So if you write like this, in that case the answer could be square root of 14 over 14. If you multiply by 2, I could simplify this a bit. So we could write this as square root of 14 over 7. And here I could write this as 3 square root 14 over 14. So that becomes the unit vector in the given direction 1, 2, 3. So I hope now the concept is absolutely clear. And let me write down what unit vector should look like. So we are saying that unit vector, let's say V, is normally represented like this and is equals to the vector divided by its magnitude. Okay? So that becomes the basic about unit vector. Now let us take up two examples which we talked about earlier. So let us try to answer this question. Write velocity vector for a car traveling southeast with speed of 60 miles per hour. I have converted this into a multiple choice question. You can pause the video, answer the question, and then look into my suggestions. So let's first understand the concept. So we have a car which is traveling southeast, that is to say 45 degrees with this. So let's say from origin traveling in this particular direction. Now you could consider any point on this. Let's say this is our XY plane, right? And southeast really means that this is 45 degrees, correct? Now we could consider any point on this. On a plane, you know, the line y equals to minus x also represents any point on this particular line, correct? So I could consider a point which is 1 minus 1. So this will lie on this line which is southeast of the origin O. This makes sense to you, correct? Now let's look into the question once again. Write a velocity vector for a car traveling southeast with speed of 60 miles per hour. So what we can say here is that the direction vector will be what? So the direction vector, let's say we call this as S, will be 1 minus 1, correct? Now the solution of this question becomes similar to what we did. So what we can do now is to find a unit vector in this direction. So first step is to find unit vector this, right? So this is our vector southeast direction, and now the unit vector will be the same vector divided by its magnitude. So the magnitude here is square root of 1 square plus minus 1 square. You get an idea, correct? So that gives you 1 over square root 2 and minus 1 over square root 2. So that becomes the unit vector in this particular direction. You could also write this as rationalizing. You could write this as square root 2 over 2 minus square root 2 over 2. Now, this is a unit vector, so let's say this is this unit vector, right? That represents a unit vector in southeast direction. So we are saying this is south for us, and this side is east. In that case, that is the unit vector. Now we want speed in this direction to be 60 miles per hour. So we'll call this as our velocity vector, and since we know this direction, and that is unit, so we'll multiply by 60. So 60 times this unit vector gives us the velocity. Does it make sense to you? Okay? And that clearly is 30 square root 2 minus 30 square root 2. So the option B is the right option. Correct? So that is how you could actually solve such a multiple choice question based on speed and velocity. Perfect. Now let's move on and take the next question. Now many times you are asked a question, can the sum of two unit vectors be a unit vector? Here we are going a step ahead. We are saying yes, it can be, but now what is the difference? So the question for you is, if sum of two unit vectors is a unit vector, find the magnitude of their difference. So that is the question for you. You can pause the video, answer this question, and then look into my suggestions. Now let's look into this question in greater details. We are saying if sum of two unit vectors is a unit vector. Now that part itself sometimes is an independent question. How do we solve it? Well, the solution is an equilateral triangle where each side is one unit. So if I have this as one vector, another vector which is 120 degrees to that vector. So what I'm trying to say here is that if I extend this and sketch another vector which is 120 degrees of magnitude 1, in that case it results into a resultant whose length will also be 1. So what we'll notice here is that we get a unit vector with angles inside the triangle being 60 degrees. So you're familiar with the with the equilateral triangle with one unit as the length. So that forms the first part, that is sum of two unit vectors is a unit vector. So you do get sum of two unit vectors as a unit vector if the angle between the two vectors is 120 degrees. Do not write 60, right? So the angle between the two vectors is 120 degrees. Now, in this part, we are looking into the magnitude of their difference, right? So we are looking into the magnitude of their difference. So let's say this vector is A for us. Let me write down A and B. Let's say this is vector A for us, and that is the vector B for us. Then what is minus B? Minus B will be in this direction, correct? So let me sketch this for you. So we have B here, so the minus will be in the opposite direction. So that becomes minus B, and clearly A minus B will now be the vector joining from here to there, right? So it will be a vector which is right. So this vector is here is A minus B vector. Perfect. So that is how you get A minus B. So we need to really find what is the magnitude of A minus B. I hope that is clear now, right? Okay, so let's work on this particular geometry. So what we know from here is that this angle should also be 120 degrees, right? Vertically No, I'm sorry. This angle should be, because here we have 60 degrees, correct? And 180 minus 60 is 120 degrees. So that is how you get this angle as 120 degrees. Now from the diagram, we know this length of A and B is same. They are both unit vectors. So we have an isosceles triangle here, right? So we have an isosceles triangle. Let's label this triangle. Let's say O, A, and this point is B, and this point is B dash. So what we find from here, that the triangle OAB dash is an isosceles triangle. Correct? So in that case, the angle at these two sides, that is the angle AOB dash, will be equal to 30 degrees and will also be equal to angle at AB dash O. So both of them will be 30 degrees. So we have 120, 30 and 30. So that shows that the angle BOB dash is equal to 90 degrees, right? 60 plus 30, which is, so that means that the triangle BOB dash is a right triangle. Clear? Now, if you look into this right triangle, then we know the magnitude of OB, since it is a unit, is 1. We also know that the magnitude of AB is equal to magnitude of BB dash, correct? Which is also equal to 1, right? So we know the sum of magnitude, which is magnitude of BB dash, is basically 2, right? So from this situation, we know that this magnitude BB dash is 2 units, correct? And this is 1 unit. And we have a right triangle right there. Perfect. 2 is the hypotenuse. Correct? 2 is the hypotenuse of this right triangle. So from Pythagorean theorem, so we can apply the Pythagorean theorem. And we can find that OB dash is really equal to square root of 2 square minus 1 square, which is square root of 4 minus 1, which is square root of 3. Is that clear? Since in a right triangle, we know, let me write down here, we know BB dash square is equal to OB square plus OB dash square, correct? That is from Pythagorean theorem. So if you rearrange, then OB dash square will be BB dash minus OB square. Right? Let me rewrite. So basically from here, I just missed these steps. So this square should be equal to BB dash square minus OB square. Is it okay? So from there, you can square root and get the answer. So you clearly see that the difference of these unit vectors is going to be square root 3, which is option D. Perfect. So I hope with this, you understand that the unit vectors sum could be a unit vector, but their difference in that case is square root of 3. I hope that helps. Feel free to write your comments and share your views. If you really like and subscribe to my videos, that would be great. Share my videos with your friends. Thanks and all the best.